Hello, my name is Marcus Collier-Wright. I'm co-founder and CTO of Neutron Star Systems, and I'm here to tell you about our disruptive electric propulsion technology. With us, the future is electric. The problem that we are solving is that current electric propulsion systems are not meeting our customers' needs. They are limited to certain operational ranges, they rely on expensive and rare propellants, and they cannot be upscaled to high powers. As a result, they cannot be optimized to customer solutions, and this leaves the full potential of spacecraft missions inaccessible. Our solution is Supreme, a next-generation electric propulsion system. We combine two key technologies, widely researched applied field MPD thrusters and industrially mature high-temperature superconductors. This combination results in a propulsion system which is scalable, efficient, and can use alternative propellants. We provide flexibility, versatility, and customizability to our customers, allowing us to optimize the solution we provide and reduce their costs. So how does Supreme stack up against the competition? To assess this, we take two metrics, specific impulse and thrust. Now, Hall effect thrusters provide a relatively high thrust but at a low specific impulse. Gridiron thrusters, on the other hand, provide a much higher specific impulse, but their thrust is limited. And both of these technologies are limited to the respective section of the chart. With Supreme, we can offer the best of both worlds. We can offer high specific impulse, we can offer high thrust, we can offer the best fit for the needs of the customer. Supreme has 5 critical competitive advantages. A wide propellant flexibility, allowing operation on alternative propellants such as argon and ammonia, which are 2 orders of magnitude cheaper than the existing status quo xenon. And this also opens new possibilities for hybrid propulsion architectures. The technology is simple and robust and is backed by over 60 years of research heritage in 6 different countries around the world. The technology is highly scalable. We can scale up to higher power classes with minimal mass and volume penalties and over a wider range of power classes than any competitor. And the technology is throttleable, allowing us to operate over a wide range of conditions, which translates to propellant and cost savings. This combination of competitive advantages allows us to offer a unique solution to a wide variety of mission scenarios which form the basis of our vision. We have near-term market entry scenarios in small sats and constellations and geocommunication satellites, and we can also enable future multi-use servicing vehicles for the likes of debris removal and decommissioning, orbit raising, satellite refueling, and satellite maintenance. In the midterm, we can help enable a lunar-based economy, starting with lunar gateway logistics and with applications such as lunar servicing and cargo transfers from the Earth to the Moon. And in the far term, we can enable Mars missions, with cargo transfers to Mars, crewed Mars missions using electric propulsion, and the establishment of a Mars gateway, as well as science and exploration missions and asteroid mining applications. Our vision is to enable this next generation of spacecraft missions. To put this into some context, we've evaluated the opportunity on offer here. We see all of these market scenarios coming to the market on regular intervals as a direct consequence of our technology being developed, and we predict annual revenues of over 500 million euros by the year 2039. Our value proposition lies in our ability to reduce the cost of almost any mission through the use of cheaper propellants and more efficient operation. For our near-term market scenarios, we can save 10 million euros for a geocommunication satellite, 20 million euros for a science mission, and 30 million euros for a small sat constellation. And we can see large savings on cargo missions, such as 90 million euros for moon cargo and 320 million euros for Mars cargo. Our core management team combines over 80 years of industrial experience and brings together all the competences needed to make this business a success. Manuel is an expert on superconductors and innovation management. I'm an expert on electric propulsion. David has put several pieces of equipment in space, including a successful electric propulsion thruster, and Georg from the University of Stuttgart has overseen the development and experimental testing of the most advanced MPD prototype anywhere in the world. To anchor our operational strategy, we've established several customer and partner relationships. Based on dialogues with our existing customer portfolio, we see that there is a demand for the technology. Based on the endorsements we have received from the likes of ESA and OHB, we see that the technology can be developed. And we've established several partnerships with leading entities, and this is how we will build the technology. What we have in our hands are the building blocks of a technology which can revolutionize in-space propulsion. With the backing of ESA, we can bring in a new era of scalable, efficient, versatile, and economically superior space propulsion. We can secure Europe's position as the leader for the future high-power market and secure non-dependency against the threats of Russia and China. Thank you for listening.